coldest temperature ever recorded in Antarctica and globally was minus 89.2 degrees Celsius. This was recorded in 1983 at the extremely remote Vostok station. Satellite measurements have suggested temperatures can drop even lower, all the way down to minus 93 degrees Celsius. It's cold. But most of Antarctica isn't that cold all the time. Around the coast where most activity happens, temperatures in the summer are usually close to around 0 degrees. And in the winter can drop down to minus 10 to minus 30 degrees in the coastal areas. It's only in the interior where the temperature extremes really happen. And the ocean around the continent sits just above freezing, often around 0 degrees, and sometimes slightly below. That's because seawater contains salt, which lowers its freezing point. Pure water freezes at 0 degrees. Seawater, however, can stay liquid down to around minus 1.8 degrees Celsius. The salt content of the seawater disrupts the formation of the ice crystals, making it harder for the water to freeze. It means down here, you're surrounded by cold in every direction: air, water, and ice. Even at temperatures close to 0, the cold behaves differently in Antarctica. This is because it's rarely still. Around the coast, the continent is surrounded by the Southern Ocean, and strong winds are almost constant. These winds pull heat away from your body much faster than still air, making the cold far more intense than the temperature alone suggests. This is what's known as wind chill, and it's one of the main reasons why Antarctica can feel so extreme. At around freezing, adding 10 miles an hour of wind can make it feel around 3 degrees colder, and that effect becomes much more severe as the temperature drops. Early explorers often wrote about this, not just the cold itself, but how the wind made it almost impossible to function. On Robert Falcon Scott's final expedition, his team had already travelled around 800 miles to the South Pole. They were then held in place by severe weather for days, unable to move. When they died, they were just 11 miles from their next supply depot, which offered the life-saving food and supplies they needed. But the Antarctic weather stopped this. This is just an example of how severe the winds can be. As you move away from the coast, this effect becomes even more pronounced. Stepping up, cold, dense air forms over the high interior of the continent and flows downhill under gravity, creating what are known as katabatic winds. These winds can reach extremely high speeds, carrying the cold air from the interior down towards the coast. These winds can actually reach over 300 kilometers an hour, around 200 miles an hour, on quite a regular basis. For a person, this would mean the heat is almost instantly being stripped away from the body. Even small areas of exposed skin can freeze quickly, and staying still for too long becomes a risk. Everything has to be managed carefully: clothing, movement, and time spent outside of a vehicle or building. It's not just about surviving the cold, it's about constantly managing it. Even emperor penguins, which are perfectly adapted to this environment, rely on staying in tightly packed groups to reduce heat loss during the extreme storms. They constantly shift positions within the group, rotating so that you have a limited time exposed to the most extreme cold conditions on the outside and rotating into the warmer center. And heading back to the coast, even being in the water offers no escape from this cold. The ocean sits just above freezing, and if you fall in, cold shock will hit almost instantly. Your breathing becomes uncontrolled, and your body starts losing heat extremely fast. It's not something you can adapt to in the moment. It happens before you have time to react. I've been in the water briefly, and it's hard to describe how quickly its impacts affect you. And even once you're out of the water, the cold doesn't just disappear. Your body continues to lose heat for several hours sometimes afterwards, and recovery takes time. So why does Antarctica get this cold in the first place? The main reason is how little energy it receives from the sun. Antarctica sits at the very bottom of the planet, where the sun stays low even during the summer. That spreads out energy over a much larger area, reducing its intensity. Then, during the winter, large parts of the continent are in complete darkness for months at a time. That removes that energy input almost entirely. So, from the start, there's very little heat energy coming in. On top of that, the surface itself plays a role. Ice and snow reflect most of the sunlight that reach them, rather than absorbing it. This is known as the albedo effect, and it means very little heat is retained at the surface. So even when the sun is present, it doesn't warm the ground in the same way that it would elsewhere. Then there's the elevation. Antarctica isn't just a flat continent, it's covered by an ice sheet that in places is several kilometers thick. That means that much of the continent that sits high above sea level, where temperatures are naturally going to be lower. And finally, isolation. Antarctica is largely cut off from the warmer air and water circulating elsewhere on the planet. Strong winds and ocean currents circle the continent, limiting how much heat can move in from lower latitudes. Unlike places like the UK where different air masses constantly mix, Antarctica is far more isolated, with cold air largely contained over the continent. The result is a system that not only gets cold but stays cold, and reinforces that cold over time. Now, we've just said that Antarctica is isolated, but not completely. It's cut off enough to stay extremely cold, but that cold is still connected to how the rest of the planet behaves. It doesn't just stay there, it has a profound effect on how the entire planet functions. Around the edges of the continent, the ocean cools and becomes denser. As the water cools, it sinks. And in Antarctica, this process happens on a massive scale. That sinking water helps drive a global system of ocean circulation, moving the cold water along the ocean floor and helping to redistribute the heat around the planet. It's part of what keeps the climate system in balance. Antarctica also acts as a kind of heat sink. It absorbs and stores the cold, helping to regulate temperatures beyond the continent itself. So what happens here doesn't just stay here. The cold that forms in Antarctica helps shape ocean currents, weather patterns, and the climate system as a whole. Antarctica is cold, incredibly cold, but it's far more nuanced than that, and far more important than a simple fact. It's shaped by how little energy it receives, how the energy is reflected, how isolated the continent is from the rest of the planet, meteorologically, and how that cold doesn't just stay here, it drives ocean circulation, influences global climate systems, and plays a role in keeping the planet itself in balance. That cold has helped shape one of the most specialized ecosystems on the planet. Antarctica isn't just one of the coldest places on Earth, it's one of the places that helps define how the Earth works.